So here we have a worksheet for nuclear equations. So just want to go through some of these examples and practice what we just learned about nuclear decay. So as I said before, the first thing that you want to do is you want to look at what is happening on the left-hand side versus the right-hand side, both in relation to, it's a bit too dark, isn't it? In relation to atomic mass and in relation to atomic number. Make sure I don't highlight too dark. Yep. So in this example, first of all, we are looking for some kind of emission, and that's because we have a blank on the right-hand side. So it is an emission, it's definitely not electron capture. In fact, electron capture is going to be pretty easy because it's the only thing that you see on the left-hand side. So if you have some kind of nuclide plus a blank, then you know it's electron capture because everything else is emission. So then what you want to do is you compare the mass. Well, that's not very dark, is it? I want to use my pan. Okay, so you've got 209 on the left and 209 on the right. So mass isn't changing. However, you are changing atomic number because you're going from, is that the right tool to use? I think so. You're going from, no, it's not. Never mind. I don't know which one. Oh, because I'm in a different app than I usually use. Never mind. Mondays. Okay, so you're going from 82 to 83, which means you are increasing the number of protons by 1. So because mass isn't changing, that means that you must be changing a neutron into a proton. So that means the neutron is releasing a negative charge so that it becomes positive. Now, what kind of decay is that? Is it alpha, beta, positron, or gamma?
Beta or not?
Yes, exactly. It is beta. Because the beta emission is when you basically kick out an electron or a negative charge. Good. Okay. In number 2, they're actually giving you what kind of emission it is. This is alpha emission. So then your job is basically to figure out what element do we have now. So we have to probably write in our atomic mass and number first, and then we'll go to the periodic table and figure out which element this is. So we are decreasing mass by 4. So we start with 234. We're going to go to oops, that's the wrong one. Oh, okay. There we go. So we're going to go down to 230, and our mass decreases by, our atomic number decreases by 2. So we go from 92 to 90. Now we go find our periodic table. And we find number 90, all the way in the bottom. There we go. There it is. Thorium. So then we go back, and we put in TH. Okay. Now, number 3 is interesting. I don't actually know what kind that is. That is like an alpha capture, but then it's also releasing a hydrogen. But anyway, it's fine because we can figure it out. So what we have on the left-hand side, we have an alpha particle plus nitrogen 14. Not really sure why the hydrogen is there, but that's okay. We're going to go with it. So why it doesn't matter is because, as I said, the conservation of mass, everything on the left-hand side has to equal everything on the right-hand side. There's only one blank, so it's pretty easy to do the math and figure it out. On the left-hand side, we have a total atomic mass of 18, and this is going to account for one of them. So we've got 17 left. Let me do that in a different color. We got 17. And then our atomic number, we've got 2 plus 7 is 9. This accounts for one of them. So what we're left with is 8. Yeah, so we go back to the periodic table. Number 8, oxygen. Go back here, and is oxygen. Okay, let's do one more. This one is losing a neutron. So again, even if it's, because I just downloaded this worksheet this morning, even if it looks weird, just rely on the conservation of mass and just make sure that everything on the left equals everything on the right. And the identity of the element that you're filling in is going to be according to atomic number. So on the left-hand side, we have a mass of 65 plus 1, that's 66. But this accounts for 1, so it's still 65. And our atomic number is 29. The neutron doesn't add to that. And we've got 1 here, so this is going to be reduced to 28. And we go here, 28, that's nickel. So we go back, and it's nickel.